In this video, we demonstrate reduction of order via an example. Example. Rewrite the system x double prime plus 3x prime plus 4x minus 2y equals t cubed. Y triple prime equals 2x plus 3x y prime plus x prime y prime plus the cosine of t as a first order system. So we'll start by slightly rewriting this first equation. X double prime equals negative 3x prime minus 4x plus 2y plus t cubed. Now we define our new variables. x1 equals x, x2 equals x prime, y1 equals y, y2 equals y prime, y3 equals y double prime. We differentiate each equation. x1 prime equals x prime, and this equals x sub 2. X sub 2 prime equals x double prime equals negative 3x prime minus 4x plus 2y plus t cubed, which we will then rewrite according to these equalities. So for example, this x prime is x sub 2, and so forth. X sub 2 prime equals negative 3 x sub 2 minus 4 x sub 1 plus 2 y sub 1 plus t cubed. Y sub 1 prime equals y prime equals y sub 2. Y sub 2 prime equals y double prime equals y sub 3 y sub 3 prime equals this. Y sub 3 prime equals the third derivative of y equals 2x plus 3xy prime plus x prime y prime plus the cosine of t. Again, we'll translate this into our new variables. Y sub 3 prime equals 2x sub 1 plus 3x sub 2 plus x sub 2 y sub 2 plus the cosine of t. Copying our answers cleanly, we get x sub 1 prime equals x sub 2, x sub 2 prime is negative 3x sub 2 minus 4x sub 1 plus 2y sub 1 plus t cubed. And y sub 1 prime equals y sub 2. Y sub 2 prime equals y sub 3. Y sub 3 prime is 2x sub 1 plus 3x sub 2 plus x sub 2 y sub 2 plus the cosine of t. In this video, we have seen via a practical example how we can reduce the order of a system of differential equations. Although doing so increased the number of equations, from 2 to 5. It is a fundamental tool of numerical differential equations due to the relative ease that mathematical software can deal with such problems.